Question if the atomic structure we learned in school is the complete picture? What if the knowledge we've accepted for years, the very bedrock of our understanding of the microscopic world, is not as complete as we thought? Imagine the possibility of new discoveries, of revelations that could change how we perceive the atomic structure. The power of questioning established knowledge is the crux of scientific exploration. Today, we delve into a discovery that might just turn the atomic model we learned in school on its head. Before we explore the new discovery, let's first refresh our memory on the traditional atomic model. The atomic model that most of us are familiar with is the Bohr model, named after the Danish physicist Niels Bohr, who proposed it in the early 20th century. In this model, atoms are made up of three fundamental particles: electrons, protons, and neutrons. Electrons are tiny, negatively charged particles that orbit the nucleus of the atom, much like planets orbiting a star. The nucleus at the heart of the atom is made up of protons and neutrons. Protons are positively charged, and neutrons, as the name suggests, are neutral, carrying no charge. The Bohr model pictures the electrons in specific orbits around the nucleus, much like planets in a solar system. Each orbit can hold a specific number of electrons, and these orbits or energy levels are quantized, meaning electrons can only exist in these discrete orbits and nowhere in between. The positive charge of the protons in the nucleus balances out the negative charge of the electrons, resulting in an atom that is overall electrically neutral. The number of protons in an atom determines the atomic number, and thus the identity of the element. For example, if an atom has one proton, it is hydrogen. If it has two, it's helium, and so on. The Bohr model has been incredibly useful in explaining many aspects of chemistry and physics. It's been instrumental in understanding chemical reactions, the formation of compounds, and even the emission and absorption of light by atoms. But science, as we know, is about refining and improving our understanding of the universe. And while the Bohr model has served us well for over a century, it's not without its limitations. It can't explain certain phenomena like the behavior of atoms in magnetic fields or the properties of atoms with many electrons. This model has served us well for a century, but it seems that it may not be the absolute truth. Now imagine if we could look even deeper into the atom. What could we find? With the advent of artificial intelligence, we are no longer limited by the constraints of human perception. AI gives us the ability to dive deep into the subatomic world, sifting through mountains of data in the blink of an eye. One such application of AI is in the field of particle physics. Here, we use particle accelerators, colossal machines that propel particles at near light speeds. These accelerators allow us to peek into the very fabric of the universe. But they also produce an enormous amount of data, far more than any human could ever hope to analyze. This is where AI steps in. By employing machine learning algorithms, we can sift through this sea of information, looking for patterns that might otherwise go unnoticed. Recently, such an approach was used to analyze data from these particle accelerators, and what it discovered was nothing short of extraordinary. Inside the proton, one of the key components of an atom, our AI detected something strange, something that didn't quite fit with our existing models of atomic structure. This wasn't a flaw in the AI or an error in the data. No, this was a genuine scientific discovery, a hint that there's more to the atom than we've been taught in our textbooks. This finding isn't just a minor anomaly. It's a sign that our understanding of atomic structure, a cornerstone of modern science, might not be as complete as we once thought. It's like finding an unexpected room in your house, a space you never knew existed. It's a discovery that could change everything. This is the power of AI. It's not just about making our lives easier or more efficient. It's about expanding the boundaries of our knowledge, pushing us to question, to explore, and to discover. It's a tool that can reveal the hidden mysteries of the universe, one proton at a time. This discovery suggests that our understanding of the atomic structure isn't as complete as we once thought. So what exactly did the AI detect inside the proton? The AI, with its advanced algorithms and computational prowess, detected something truly fascinating. It found evidence of a substructure within the proton, something that was never part of the traditional atomic model. This substructure is not just a random arrangement of particles. Rather, it appears to exhibit a level of organization that we have never seen before within a proton. The AI's findings are based on high-resolution data collected from powerful particle accelerators. These machines smash protons together at nearly the speed of light, producing showers of particles that are then meticulously analyzed. The AI was trained to sift through these colossal datasets, looking for patterns and anomalies that might elude human researchers. And that's exactly what it did. The AI detected patterns in the data that suggested the existence of a hitherto unknown substructure. The traditional atomic model, which we've held as the cornerstone of our understanding of matter for so long, has always depicted protons as indivisible particles. But the AI's findings challenge this long-standing belief. This discovery is akin to peering inside a Matryoshka doll and finding another one nestled within. Just as we once thought atoms were the smallest units of matter, only to discover they were made up of protons, neutrons, and electrons, we're now faced with the possibility that protons themselves might not be as fundamental as we once thought. So, what does this mean for our understanding of atoms and matter? Well, it's like realizing that the alphabet contains more letters than we initially thought. It expands the vocabulary of the universe, adding a new layer of complexity to the atomic model. This discovery might have far-reaching implications, changing the way we understand atoms and, by extension, matter itself. What does this mean for our understanding of the atomic structure, you may ask? Well, it's quite profound. This discovery, made possible by artificial intelligence, has the potential to revolutionize our understanding of the atomic world. It has the power to change the very foundations of atomic theory, that cornerstone of science we've held as truth for so long. Consider what it could mean for the field of chemistry. The atomic model forms the basis of everything we know about chemical reactions. It's the reason we understand how elements combine to form compounds and why certain substances react the way they do. If we have to revise our atomic model, we may have to rethink some of our fundamental principles in chemistry. This could lead to new insights and even the development of novel materials or drugs. And then there's physics. The atomic model is deeply intertwined with our understanding of quantum mechanics, the theory that describes the smallest particles in the universe. If the atomic structure is different than we thought, it could change our understanding of quantum phenomena. This could have implications for everything from the development of quantum computers to our understanding of the universe itself. But perhaps the most exciting implication is the potential for new discoveries. This finding is a reminder that we still have so much to uncover about the world around us, and that our current knowledge is, at best, incomplete. It's an invitation to scientists around the world to delve deeper, to question, to explore. It's an opportunity to push the boundaries of our understanding and to make new groundbreaking discoveries. Yet, as is often the case with scientific discoveries, this one raises more questions than it answers. What exactly is this strange thing inside the proton? How does it affect the atom's properties? And how does it interact with other particles? The discovery, while exciting, also raises more questions, and it's clear we have much more to learn about the atomic world. So, were we taught wrong in school? A question that might have been echoing in your mind since we started our journey through the atomic structure. What we have unraveled today is a new discovery, an unseen layer of the atomic structure, detected by the keen eyes of artificial intelligence. It has shown us that there's more to the proton than we thought, adding an unexpected twist to our understanding of the atomic model. But does this mean our education was flawed? Not quite. Science, you see, is not a fixed entity, but an ever-evolving discipline. What we learn in school, or anywhere for that matter, is based on our current understanding of the world. And this understanding is always subject to change, to refine, to evolve with every new discovery, every new perspective that we gain. In this case, AI has given us a new lens to view the atom, to further our knowledge of this fundamental building block of matter. The implications of this discovery are far-reaching, potentially transforming fields from quantum physics to chemistry and beyond. So, while we weren't necessarily taught wrong, we were taught what was known at the time. And now, our knowledge of the atomic structure is evolving thanks to AI. It's a fascinating journey of discovery and learning, and we're all along for the ride.